Good morning, everyone. As the introduction said, my name is Bryce Verdier, and I'm here to teach you about using Vault to better protect your secrets. I like presentations with agendas, so that way you know exactly what's going to happen and what I'll be sharing with you today. So, one of the reasons that I'm doing this talk is I've had experience doing both information security, system administration, and Python programming. Usually Python is the glue that I use between all of those jobs and roles. Is my time spent doing system administration and programming where I really started to realize how often and how much we programmers tend to That's okay. All right, we good? Yeah? The guy's gone. I'll continue, and we'll play with it if we need to. How much we programmers tend to, make shortcuts and add usernames and passwords right into our scripts. Sysadmins are really kind of notorious for this. And when becoming an information security engineer, I got to experience firsthand what this can do and how it can ruin a day. So just so we can all be clear, I'm going to say the word secrets a lot in this presentation. And secrets can mean many, many things. Generally, when we think of authorization, we think of just username and passwords. But in today's day and age, there's also AWS to deal with, IAM and EC2 keys, any other form of authentication token that may exist for a cloud service. Generally, things that you do not want shared in the open spaces, things that you want to maintain and keep private to your work environment. So if it's something that you would feel ashamed of if somebody got a hold of, you can consider that a secret for this presentation, and maybe even going forward. And just first disclaimer, I am not here on behalf of HashiCorp. I am doing this because, again, this is something that has affected me and I believe is kind of everywhere within our work environments. I believe that we as programmers should try and do the right thing and try and not keep secrets just in our scripts. So yeah, I'm not supported by HashiCorp. I'm not sponsored for this trip. I'm doing this just because I think it's the right thing to do. So I didn't realize the text would be so small. The information security industry for a long time has known that GitHub in particular, people make mistakes. Usernames and passwords just end up there, even by accident, not necessarily somebody trying to do something malicious, but code change at 3 a.m. and a git push to the wrong place, mistakes happen. So we've known this for a little while, but just recently, this article was from March of this year on Slashdot with the title, "Over 100,000 GitHub repos have leaked API and cryptographic keys." This is, I believe, the start of the realization that this is a real thing. Sure. Better? Awesome. Okay. If I get a thumbs up in the back, then that means things are good. So again, over 100,000 repos potentially carry things that, again, you wouldn't want shared with the general public from either a work environment or even your own projects. And it's really not hard to look for. Here's a public SSH key in the Git log because Git never forgets. That's for all those who understand it. That's why it's red. Git never forgets. So if you actually make this mistake, you want to make sure to clear your GitHub log. But again, general honest mistakes. I believe this is a Docker configuration. I took the screenshot a couple of months ago. I had to protect the innocent, I smudged out anything related to the repo and the company that this belonged to. So that's why things are fuzzy in various places of the photo. But again, completely out there in the wild, somebody's probably found this as well and is using it for running an EC2 instance under somebody else's dime. And when you see these things and all of them, that's kind of the emotional reaction that I have. This is something that we should know better, but again, accidents happen. It's okay if you can eventually discover it and clean it up. So as I've been hinting through the beginning of this talk, we've talked a lot about how this happens. Again, mistakes, stuff like that. Some of the other reasons is, at least in the US, I'm not exactly sure about Italy and parts of Europe, there's a lot of this cliche of everybody is responsible for security. This is a nice platitude, if you will, but I feel like it kind of doesn't do justice to the bigger issue. Mainly just because everyone's responsible, who's accountable? Who's going to be the one that ends up getting that phone call at 3 a.m. when a secret's been discovered on GitHub somehow, and you need to go through the process of cleaning this up? That's the accountability part of this. And as I said, I've spent time being a programmer. I understand the priority of having to get bug fixes and features out the door quickly. Security is not something that is first and foremost for most engineers. We are all told that we need to be aware of it, we need to pay attention to it, but sometimes it's not in our sprints. Sometimes it's not in however we do our development. It's just not prioritized. So if we can start to add security to the application as a whole and do this, we can kind of remove some of the difficulties that come with this. And again, I'm introducing HashiCorp's Vault as a possible solution for this. There are others out in the industry. Maybe some of you are using them, but this is an alternative. HashiCorp likes to describe Vault in this way. This is an accurate technical description, but it's not a good elevator pitch. It's not something that you're going to be able to bring to your very busy manager or very busy CTO as a reason for doing this. You need something quick and a little bit more tangible. So I like to think about it and talk about it as this merging of both a password manager and a configuration manager. Here I have icons for both LastPass, which I believe is a popular web-based password manager, and the Zookeeper logo, which I don't know about here in Italy, but in the US it's pretty common to use Zookeeper for a configuration server. So as a quick understanding for password managers, for maybe some people who aren't familiar with them, it's simply a desktop application or maybe a web service that helps you store and generate passwords for all of your accounts. I use them. I recommend people start to use them as well. It helps generate random passwords, the most secure kind that you can get, and it keeps it in a single place. Generally, when using a desktop or any form of password manager, you have what's known as a master password. So the application opens a single encrypted file, so you can interact with it. When you're done, you can then go and seal it up, close it, and knowing that the contents of the file are safe. So a couple of things just to take away going forward about password managers. In order to interact with it, you need to use a master password to open it, to unseal it, to access its contents, and you can close it when you're done using it. And by default, the contents will be encrypted. So it's a good thing to have. As I said, I'm using Zookeeper as an example for the configuration management. There are others, but I just thought it would be easier going forward with this one, because I believe it is more familiar to the audience. Zookeeper is, as this image shows, kind of like an API for grabbing configurations. I know in this modern era, people like to go and put configurations in Docker images. but some people don't still. Some people don't necessarily use Docker still. So this is a way to deal with sending out of applications and still maintaining and having the configuration be separate from the code and the deployment. Usually when a microservice spins up, it'll make an API call, grab its information, and run from there. Zookeeper likes to run in a Unix tree-like structure. So you kind of think of it like a key value storage. You go down the path of what you're trying to find, and you get it. Better? No? Okay. Well, third time's a charm. So here in this case, key value storage, you're going to go through like root to config to app1 if you want to get the information for, say, the DB host, at which point it'll return localhost. Here's the Kazoo library with a very simple example from their website. You just initiate a client, point it to the server, and just go down the path to get the information you're after. Again, in this case, it should return localhost. I would also like to point out in this case, no authentication, nothing stopping any client from just making this request and getting this information here. Something we should be aware of as well. So for thinking about configuration management going forward, this is an API. It's an API server, plain and simple. And you have the tree-like structure to getting the information that you want. So I'm going to provide a nice little demo to show how to use this service. I'm in this talk, I'm doing it on a Docker image provided by Vault. But when you run it in developer mode. So there's a couple of differences that I really want to emphasize if you want to do this in your work environments and at home. No TLS certificate is supplied by this Docker image. Since these are things that you want to keep secret, you also want to make sure that it's encrypted in transit. So again, certificates, you want to use those. Whether you use Docker or not to store this application, you want to make sure that you're going to provide proper system hardening and monitoring. You're now putting really important things in one location. Any malicious attacker who hears this will just start salivating. So you want to make sure that you are protecting this and being aware of whenever anybody is using this service inappropriately or trying to. When I spin up the Docker instance, you're going to see both one unseal key and one root token. When you run into production, you get 5. You want to think about how you're going to properly save and store those and maybe possibly distribute them. It might be a good idea to make sure that no one person can completely unlock the vault. So that way you have a little extra security there. But again, that's up to you. As I just mentioned, it gives you a root token. This is like the root account in Unix, a godlike token. So you want to make sure this is really protected. HashiCorp recommends deleting it, but if you're uncomfortable with that, just keep it in a really secure place and try not to use it. Again, like the root account. So let's have some fun with some demos. So going to start up the Docker instance here. If I can type my password correctly, which I can't. Yeah, I do. Come on. There we go. So we'll scroll up here. We see that the service has started to run, and we've got our unseal token and our root token. I'm just going to copy this, come over here. Vault, as I said, works on like an API level. There are languages that provide libraries. Just for the simplicity of this demonstration, I'm just using bash scripts and its API, just HTTP API. Here we're just going to show you just it coming up. Also in the previous, and when I showed you the script, I'm piping all the information through GQ. For those unfamiliar, GQ is an application in bash to go and pretty print JavaScript, which is why this is kind of nice. We can see that it's already been unsealed by the second line, and that's up and running. So we're good to go. It's a new instance, but let's take, oh yeah, need that. It's a new instance, so it should be empty. Here I'm asking kind of the service what secrets are currently in it. Just grabbing the metadata under the secrets directory. So obviously, in order to have a decent presentation, I'm going to need to upload secrets showing that. I've basically in the third line there, I've recreated the information from the image earlier. Host, username, password, as well as the data that it contains. Interact, you want to throw up, you want to pass it JSON, blobs, and that's pretty much all it is. So let's do that. So it's succeeded. And you can now see when actually using the API, we've now got our information now hosted inside Vault. So far, I've been using the root token, which I've told you don't use. So we're going to eventually create a new token. When the root token creates a new token, it's going to create another root token unless you tell it to do something different. In Vault, you are able to configure tokens by what are called policies. So just to briefly review that. By default, you get two policies, default and root. We don't obviously want to create a root token for the case of demonstration. So we'll be using the default policy. But with default or defense in depth kind of mentality, we can see that the default policy is really rather long. You may not want everything in there depending on your situation. There's nothing wrong with it, but maybe it doesn't meet your needs. I'm showing it so that way people are aware of it going forward, that you can tweak it however you need. So here, I'm going to create a new policy specifically for the app1 secret. Because of that tree-like structure, I have two paths in here. The first one for the very top, and again for anything underneath it. Anybody familiar with database administration should be able to see the create, read, updates. And these are the permissions that I'm going to give this token so it can interact with the server appropriately. So I've now created a policy. We come back here. Oh, nope. And we can now see that there's a new policy known as app1 for simplicity's sake. So let's create a new token. And as you can see, we now have a new token. Another thing to be aware of by default, when creating new tokens, they have a lifespan of 276,000 hours. This works out to about 31 days. After that time, if you do not juggle it, it deletes itself. There are ways to deal with it and manage it, but that's kind of outside the scope of this presentation, which is really just supposed to be introductory. But I really want to make sure people are aware of it so you don't shoot yourself in the foot later. So just using a quick example, this might be something that you see in the wild, a simple Python script, where the global variables might include, information that you don't want shared. Things that when that Git repo actually hits public GitHub, again, might make you a little sad and embarrassed that it's out in the real world. So for just a simple example, we're going to change it. Since I've done it before, it's pretty easy. Let's do this. That looks better. So with Python, there's libraries for almost everything. Vault's library in Python is known as HVAC. In this script, we're going to initialize a new client, like the Zookeeper example, point it to the server, and just to keep feelings or just to keep similarities with the scripts before, I'm just taking in a command line argument for the token. Next line is just doing the actual API call, getting that information, and just printing it out. It comes back as a dictionary on success, so that's how we're accessing the information. It's pretty simple in and of itself. The benefit of this is if this ends up showing up on GitHub for whatever reason, all you're now really sharing is a server name and a token, and the token can very easily just be replaced. So again, this was the bad script. This is the new script. If we run it, there might be a little bit of a lag because now you're making an API call instead of reading straight from the script, but you can see the information is there. So again, this is an introductory session. I'm merely trying to get you familiar with the idea of what Vault is, but it can do more than just simple storage of things. It can also help you juggle your GitHub tokens. Very similarly, you can now interact through Vault or through Vault to GitHub, and now maintain tokens and secrets that way. Also, it can create and manage database users, both permanent and temporary. So if you want to give access to a database for a certain period of time to somebody, it'd be easy to use with policies to just be able to do it, give it to them for like a day or two, even control it and allow them only certain views. This has the benefit of really locking down the database to somebody you may not want to give access to. And then finally, like GitHub tokens, you can use it to manage and generate EC2 tokens and authentication tokens there as well. So now you can use Vault as a in-between to access EC2. So for this presentation, I've talked to you about who I am, why I believe we should do this going forward. We've talked about the problem. I've introduced HashiCorp Vault and spent time doing a demo showing you how easy it is to use it if you want. So finally, we're at the end.
Thank you, Bryce. We have time for a couple questions.
Does Vault provide mechanisms for disaster recovery or high availability?
It does. It does. It's I didn't want to go into it because of time limits, but it's kind of built on top of HashiCorp's console service, which provides the high availability. This is really just a encryption storage on top of console. Good question, though.
So this kind of injects the environment variables at the beginning of the application, right? So it's like it gets all the secrets right before everything else starts. We were doing that in my company at the very beginning, and then we kind of moved towards having the secrets like encrypted and available at a commit level. So like for every commit, like if you want to change the secret, it was like that. Which direction do you think is better?
I think both are fine. Because you're doing API calls using Vault, you can kind of call it whenever you need it. So it does internal caching on its own, so then that way it's not necessarily having to do a lookup every single time you access that information to help speed it up. But I think that's just going to be up to company preference, and I don't think it matters either way. Thank you, though.
We're out of time. Thank you, Bryce, again.